Um, Jules, can you confirm that the live stream's all up and running and good? Yeah.
It is, yes.
Ooh. Okay, cool. Well, in that case, let's get started then. So, hi everyone, my name is Louise Capener. I'm part of the Computational Social Science training team at the UK Data Service, and I'm going to be running today's Code Anxiety Club alongside my colleague Jules Kasma and also Salwa Qureshi might join us at some point. And they'll be manning the YouTube live stream chat. Just a note about that. So yeah, before we get started, we're currently live streaming to YouTube, and these sessions are supposed to be quite interactive and low stress, and just a good opportunity for any of you to post any of your comments or questions about the content that we cover. So if you would like to get involved, then it's important that you make sure that you're signed into your YouTube account, so then you can post some comments, which Jules can then read out during the session. And then I can, respond, give you some hands-on help. But please bear in mind that there is a slight delay in live stream, around 30 seconds or something. So if you wonder why I haven't answered the question, that's what I'm probably going to get to. I realize as well that I'm super overexposed. I don't know why. So yeah,
Yeah, are you transmitting from the sun?
I don't know what's going on. We'll just have to roll with it. But yeah, just a bit of advertising for our next and final code anxiety session, which will be a little bit different from our previous sessions. It's going to be a very open Q&A where you'll have the opportunity to ask anything, ask about anything that's maybe still not clicking, whether that's about the command line, Git, or any of the coding concepts that we've covered, or maybe you've just missed everything and you just have a general question about coding. So come along to that if you find that interesting. But for today, we're going to be diving into debugging, which is the art of finding and fixing errors in your code. So we'll cover some of the most common mistakes that beginners make, and we'll learn how to use the debugging tools that are built into your IDEs, so that's your integrated development environments. So that's things like Visual Studio Code, which is what I'm going to be showing for our Python users, and also we're going to be using RStudio and their built-in debugger for those that are using R. And finally, we're going to finish with an important concept that's called variable scope, and we'll get a little bit hands-on with that as well. So first, it might seem like a silly and obvious point to make, but I'm going to go ahead and make it anyway, and just say that, debugging is completely normal. So even experienced programmers will spend a significant portion of their time debugging. It's a really, really vital skill. And rather than being a sign that you're bad at coding, it's just part of the process. One thing about error messages is that they can seem bizarre and confusing at first, and whoever named them in Python and R, just, I don't know what was going on there, but some of them seem really cryptic, but once you get familiar with them, it's actually not too bad. And you'll also realize that most bugs that you come across are actually quite simple to fix. So yeah, good to start on a positive note. So let's go into a few of the most common beginner errors. So you can see that we have this handy table with the error type and some examples of how they apply in either Python or R. So first things first, we have syntax errors. And I realize I haven't yet introduced the concept of programming syntax, although if you attended previous sessions, I probably have. But basically, it's the set of rules that dictate the structure and the format of a programming language. So you can think of it like the grammar of a programming language. And yeah, those of you that attended our previous workshops will have realized that Python and R have different syntax. So there's different rules governing these two languages. So you come across some of these differences already. So you'll remember that, for instance, in R, we assign variables using that little arrow operator. Whereas in Python, we use the equals operator. So we've already touched on a few of these differences. But so let's go into some of the error types. So here you can see an example in Python of a syntax error. Okay, so we're missing a closing bracket for our print function here, right? So if we run this, we're going to get a syntax error. Okay, that's what's going to show up in our console. And we will be doing a bit of hands-on with these now. So I know it's going to be a little bit theoretical for now, but then we'll get into some of the hands-on stuff. So we will demonstrate some of this. And then with R, we have a missing comma. in a function. So you can see here, we want to get the mean of these three numbers, but we forgot a comma between 2 and 3. So again, that would flag as a syntax error. The annoying thing is in R though, is that it doesn't always tell you where the syntax error is, which is really, really frustrating. I think Python does a slightly better job of this, but for R, you can be staring at your work for ages and thinking, oh my God, everything looks fine. And it's a row comma or a row bracket that hasn't been added. And particularly brackets get me a lot in R because you have to wrap quite a few things in brackets. So yeah, just bear that in mind.
Nested brackets as well can really throw you for a loop.
That's the word I was looking for. Yeah, when you're getting, a few functions in a row, which each require a bracket, you may be dealing with 3 or 4 brackets. It can be very easy to forget to add that. So yeah, that's a very, very good point about nested brackets. Then we've got name errors. So these happen when you misspell a variable name or you try to use something that doesn't exist. So here we've typed print instead of print, so missing the T there, and that's going to flag as an error because print is not a function, but print is. And computers don't like vague language. They won't just guess, even though it seems pretty obvious that we're probably going for the print, and we've got a nice print-like statement here. Your computer doesn't work like that, unfortunately. And again, we have an example in R where we're missing this lowercase, so we've got a capital here. And that's important to remember that coding languages are what we call case sensitive, so it matters if you use lowercase or uppercase, right? So most function names are going to be lowercase. It won't just, like I said, a person would know, well, that's the same function, right? But your computer needs you to spoon feed it the exact function. So keep that in mind. You'd get an object not found error there, and that's because there's no such function as print with a capital P. So then we have type errors. So remember, we've touched on different data types. So you've got strings, that's data that's wrapped in these little quotation marks here. So that's textual data. And then you have integers, so they're like whole numbers, and then you've got floats. So floats are like 0.75 or whatever. So you've got lots of different data types, and you're gonna have to bear that in mind if you're trying to complete a certain operation. So here we've got we've not converted our 5 here from a string to an integer. Okay, so when we try and add these together, that's going to flag a type error because we can't add a string to a number. We can combine them as textual data, but to do that, we have to wrap them both in quotes. I'm pretty sure, right? So yeah, and in R, again, that's going to flag as the wrong data type. And then finally, a lot of new coders are going to forget to properly indent that code, which is super, super important if you are a Python coder. For instance, when you create a function, you need to make sure after you've created the function, after the little colon, you've named it whatever, you need to then indent the function's contents. And also, this is going to apply to things like for loops and other various times in Python when you're going to need to indent. Whereas R users, you're really lucky in that you don't have to deal with this. So again, this is where we see different strengths of different programming languages because, like I said, the thing that really annoys me with R is those rogue brackets where I can't quite identify them, but I don't have that problem in Python. However, I do have to make sure I'm keeping things indented properly. But some people like that though, some people think that it gives it a nice cohesive structure and it makes things easy to understand. Some people don't like that R maybe it's a little bit loosey-goosey like that, but you could experiment with either and I'm sure you'll find your preference. Okay, so let's move on. So reading error messages. So error messages are useful because they're going to tell you what went wrong and where it happened. So you'll usually get the line number, and it usually tells you why, not always in very clear language, but like I said, you will get used to the kind of language that's used. So you can see here we have an example of a Python error. Okay, so it says name error, name variable is not defined. So it tells you what went wrong. There's a name error and tells you where it went wrong, which is it's variable here. I assume we were trying to create a variable called variable, and we've made a misspelling here.
I mean, that's a bad idea for a variable name, but
I know, yeah. I did think that when I was reviewing it today, I did think you'd actually probably not want to name your variables variables. So yeah.
People do that a lot now.
Yeah. Don't do this. Name it something that's like if you've got a variable, you add in two numbers and you've got that variable is a number 25. Name it number 1 or something, or num_1. Don't name it variable. And we've also got the same error but in R, and you can see it's presented in a slightly different way. So we don't have an error type, but it's still letting us know what is wrong. So you can see the what is this object here. And the object is again variable, which tells us where in the code we've got it wrong. It's important to note too, though, that not all errors are going to be this simple to figure out. Some can be really confusing, especially when they're long or they're going to use a lot of technical jargon. And when this happens and you find yourself stuck, I suggest a few things. So first, you'll find every programmer does this, even your friend who's a software developer he's going to be doing the same things. And this is to copy the error message into Google and see if you can shed any light on the issue. So if you're in Python, you can focus on the error type at the beginning to narrow down the problem. But another really valuable resource is a forum called Stack Overflow. And that's a coding forum where the chances are your error has already been covered before in a post by another user who's facing the same issue. So someone will post their error, their code in full. People on Stack Overflow are very nitpicky about you including the full code. So if you do ever post a question on there, these can be quite unforgiving. So make sure you've got all the correct things and read the FAQs. But chances are your error has already come up before. That's why it can be such a good resource.
I've never needed to post to Stack Overflow, but I have looked on Stack Overflow a lot.
Yeah, me too. I mean, and also I sort of think, well, thank God I haven't, because like I said, it can be, I mean, it's good because they have a lot of rules so that they get full access to the problem because,
yeah, oh, it's not without reason, but there's some real dudes.
Yeah, yeah. Also, I suppose here I would be ignoring a big elephant in the room if I didn't also mention LLMs. I know that some people don't like to use them, and I would say if you are learning to code, I would maybe stay away from just trying to get ChatGPT or whatever to they call it, I suppose, vibe coding, where it just comes up with the code for you. If you do really want to get some skills down and learn proper programming skills, then you could use it to illustrate. For instance, sometimes I use it if I really can't understand where I've gone wrong. I'll maybe paste in a function and I'll ask it to walk through it with me. That's going to help you more than, like I said, just using these LLMs to sort of create the code for you. You'll gain a lot more skills if you use it as a helper in the same way that you use it on you use Stack Overflow. So that can be a good resource if you can't find anything on Stack Overflow. Yeah, so before we get hands-on and start debugging, I'm just going to cover your debugging toolkit. So all the things that you'll need to crack your code. So first things first, if you find yourself stuck, for instance, when creating a function or messing around with some variables, a really good trick is to use print statements to see what your variables actually contain. And for breaking down the inner workings of your functions, print statements are going to be vital because they really let you get under the hood of your code. And in the next slide, I'm going to demonstrate how you do this. But yeah, I tend to do that if I'm writing a long function. Maybe it's got a few calculations in there. I don't know. And then I run the calculation and I've not got the result I wanted. Well, I'll then print out the calculations. Okay, so maybe if I'm adding a pair of two numbers, I'll print out those two numbers as they were assigned, then I'll print out the result of that, and then I can sort of step back through it and see where I went wrong.
I use a lot of print statements with my text mining work because I'll want to transform some text. So I'll say print it as it stands originally, transform it in this way, print it then to show what's changed.
Yeah, that's a really good point, especially like you said for text mining, because oftentimes you're applying a function to maybe a whole column of a data set. So printing out the first row can be great just to sort of sense check that everything's worked like you think it should. So yeah, print statements are very, very important. And secondly, code comments can help you isolate problems by temporarily disabling parts of your code. So for example, if your code works until you add a specific line, you can comment out that line to then confirm that it's the source of the problem. And that helps you narrow down exactly where things go wrong. So you can see here, it's there'll be a shortcut for each of the different IDEs. So in Visual Studio Code, there's a certain shortcut, and in RStudio too. And you'll see people do this where they just comment out a huge chunk of their code, and then they'll run like maybe the first few lines of it, and then see what kind of went wrong. Another vital tool that I'll be demonstrating after we've gone through print statements are built-in debuggers that come with your IDEs, like Visual Studio Code if you're using Python, and RStudio if you're using R. So yeah, we will go through those. And finally, as I mentioned in the slide before, don't forget that Google and Stack Overflow are your best friends, and copying your exact error message into a search often yields an immediate solution. Okay, so yeah, these are a bit hideous because they're not indented properly, but I've just put them on there so that if we do upload the slides after, you can copy and paste them. But like I said, the indentation just wasn't working for me. But the good thing is to demonstrate it, I suppose. It's not too much. So what we're going to do is look at a simple example of using print statements within a function. So here we have a basic function that's written on the left in Python and on the right in R. So it should take a number as its input, double it, and then add 10. So, if we input 8, we expect to get 26. But let's say we're getting an unexpected result and we're not quite sure why. So what we do then is we add some print statements, and those are going to show us exactly what's happening under the hood. Yeah, so just a point here, I will be showing you this with working code that doesn't have any actual errors, and that's sort of deliberate in a way. So learning to use print statements for debugging when your code is working helps you understand how they operate. Then when you do have a real bug, you'll already be comfortable with using print statements to investigate it. So without print statements, we can only see the final answer. Okay, so we wouldn't have walked through it step by step. So we print the starting number to confirm what we're working with, and then we can print the result after doubling, which should be 16, and then we can print the final result after adding 10, which should be 26. So I can go through this in each IDE. So let's exit this. Let's see what we are. Let's go to Visual Studio Code first. Okay. So I was having a little bit of issues with this before, and I had to reinstall Visual Studio Code, which is really annoying because it was working up until recently. So yeah, I suppose bear with me a bit. So what I'm going to do here is you can see we have the simple function. Okay, so double and add 10, it takes a number. So the parameter here is the number, and the argument is going to be 8 because that's the number that we supply here. So we're invoking the function, and the result of that is going to be contained in a variable that we've called answer. Then we're going to use a print statement to print that final answer. So hopefully, if all goes well, I'll be able to run just this highlighted code. And this is a bit of that I was having a problem with. Okay, great, it's done. So yeah, you can see it's just I don't really like the way it's done it, but it's fine. So you can see it's gone through all the steps here, and we have our final answer that is printed out. But Again, what if it was wrong, right? Then we need to see under the hood what's going on, and a print statement is good to do that. So when you're setting up your function for the first time, you might want to add in a few print statements, or if you just notice that it's not working, you can add in some print statements. So you can see here, we've got the same function. Again, we're working in Python, so there's indentation here. So you can see that's indented all the way through to our return statement here.
Can you just increase the size of the text?
Yeah.
Zoom in a little tiny bit. Yeah, there you go.
Yeah,
yep, that's
right.
aces.
Okay, yeah, so you can see we've got a first print statement to confirm what number we've supplied to our parameter here. So what argument are we supplying, which should be 8. So we're starting with number 8. Then we've got this double variable here, which takes our 8 and times it by 2. So after doubling, that should be 16. So that print statement, we're hoping for 16. Then we've got our result. So we take the double number, 16 plus 10. So print statement after adding 10 should show 26. Okay, so let's take all this code and run this. So yeah, you can see here what's happened on your terminal output here is you've got these print statements. Okay, so you can see it says we're starting with the number 8, which is correct. That's what we supplied. After doubling, we get 16, correct. And after adding 10, we got a final answer, 26, and that print statement as well, it's giving us final answer, 26. So that's an example of how you would use print statements there. I don't know if you had anything to add at any point, Jules, just chip in.
No, I think that's a really good example of print statements. It's not only printing the value, but it's printing a text so you can understand what the value is.
Yeah. Yeah, definitely. Okay, let's zoom in a bit on here. Okay, so now we're in RStudio. What I'm going to do is I'm just going to clear this. I'm going to clear the terminal, the console. It's Control L. Okay. Right. So let's first run our function. Let's create our function. Now, what you see here is I have gone through the different panels before, but you've got various different panels here. Can't really remember what this panel is called. I suppose maybe the environment panel, but it gets
once you define stuff, it'll appear there.
Yeah, it gets populated, and it's really nice actually, and it has an advantage that way on Python in that it's quite easy to keep track of your variables in R. You'll notice now, so when we run this, our environments become populated with a function, right? So it shows you've got a function, what its name is, and what its parameters are. So it takes a number here. Then we've got our answer variable, so we'll run that. Okay, you can see we've got our answer variable here, and even before we've done that print statement, it's telling us what that value is, so that's 26. So again, another advantage that R has. In a way, you know, we don't really need this print statement here to tell us the final answer because we've already got it, but we will run it just to show the output. So yeah, you can see the output pops up on your console here, final answer 26. Now, you see I've just inserted a comment here so we can just focus on this bit, but what we want to do now is run our function again, but you can see this time it's got a bunch of print statements and they're the same ones in Python, it's just slightly different syntax. So you can see here that we have to use this paste command if we're adding text to a number, I'm pretty sure, to make sure that number shows up with the text. So yeah, that's a slight difference there with Python. And again, obviously the operators are different here. We've got the little arrow to assign values. So we've got the same print statements. So let's clear this just for clarity. Let's run it all. You can see again, it's created that function. We're going to run our answer. You can see there, because it's run the function, we've got all those print statements, haven't we? So starting with 8, after doubling, get 16, and after adding 10, we get 26, which is working as we'd expect, and the final answer, which is 26. So again, really good to notice these slight differences between programming languages. The environment panel kind of forgot about this, that it did populate things with the variables, and that is super, super helpful. If you have finished a project and you've got a million variables here, they are going to show up if you open RStudio again. So remember, if you don't want them all to show up, just clear those objects. So let's see what's next. Gonna get on my phone because I don't have my screen today. Okay. So what we're going to do now is we're going to practice using VS Code's debugger with some simple code. So what I'm going to do is you can follow along as well. The slides will be uploaded. So I mean, I suppose it's slightly annoying because you can't just copy and paste this. But you can watch me do it, and you can go back after the slides have been uploaded and go through it yourself if you'd like. But what we're going to do is we're going to copy this basic function into a new Python file. And all it does is it just adds 5 to a number. So we're going even simpler this time. So then what we do is, so all of these instructions are for VS Code. So let's minimize that and Visual Studio Code so we can do it. Okay. Thanks. Okay, right. So let's go to our debugging file here. So I'm not sure what I do that. Sorry, just moving the toolbar away. It always just appears over the stuff that you actually need to access. Okay. So let's clear this terminal. Will this work? Oh no. Is there a shortcut? There we go. Okay. So what we're going to do now is we're going to use the debugger. Okay, so you can see here there's a little run and debug icon. But before we do that, we're going to place what's known as a breakpoint. So what this means is that the debugger will run all of these lines up until here, and then it's going to tell us a little bit about our variables. So if we click run and debug, so you can see here, it's kind of doing what the environment panel does on R. So it's telling us what variables we've created. And importantly as well, it also tells us something about scope, which we'll touch on at the end. But basically we have different types of variables. There's variables which are known as local variables, which work within a function. And there's global variables which we can assign outside a function that can be called within functions. I will give a better explanation at the end, but yeah, basically here you can see it's telling us, okay, you've created 2 local variables here because they exist within this function. You've got a number, so your number is 10, and that's right. And the result is 15. We've created no global variables, so that's not been populated. What you can do as well is you can use the debugger to basically step through each line. And what that'll do is if you want to step through each line at a time, it'll populate those variables as you go through. What I've done here is I've just run the debugger. You can see here, you can use at the top, you've got this step over or step into. And if you step into the function, for instance, it'll basically populate some more information, which some of this is not very useful. I'm not really sure. Yeah, like special variables here, you're not really going to be using this that much. So I would probably say if you've got a very simple function like this, just go ahead and run the debugger. Don't bother stepping through things. But if you're working with, lots and lots of variables and, you're becoming more of an intermediate coder, then you might want to step through your function a bit more. Okay, so that's our debugger in Visual Studio Code. Let's go and do the same thing, but in RStudio. Okay, so let me.
Just to let you know, we've just gone 2 o'clock.
We are actually at the official end of the code anxiety session, but for those of you that would like to stick around, I do have more time, so I'm fine to continue.
I'll stick around with you.
I'm sure, yeah. If you do have any other stuff that you need to do, Jules, don't worry, you can
Yeah, it's all right.
there. Right. So we're going to do a little bit of debugging in R. So to debug, basically, first thing we need to do is run our function. What we can do then is we can use this debug command, and basically what we do is we can supply our function with an argument. So I could do add 5, and instead of supplying, because I haven't run this line of code here, this add 5 with the 10 as our number, I could just do 5, okay? So we're expecting the outcome to be 10. If I press enter, oh, let me try that again.
To go the other way? Is it 5, then add 5? I don't know. I've never used the debug function in R.
No, it's fine. It's working. Maybe I do need to run this. Although I'm not sure why. Let me try again. People can't find. I created it. Yeah. Let's try that again. Debug. Yeah. So what you need your function. Okay. Just without an argument? No, that doesn't seem to work. It came up before. I was using it. It was fine. Okay.
Yeah. It worked.
And then what do we do? So again, you can basically in when we were showing it in VS Code, we could step through each line, right? And the same applies here. So we can use either shortcuts or we can use these buttons here. And basically, you press next, you go on to the next line, and you can go then on to the next line, and you can type in. So, for instance, if you want to see the values, you can type in number or result. So this allows you to play around with things in the console. So you might think, well, I've already got this here. Why do I need it? Well, it just creates those variables in a nice little sandbox, so that you can play around with it without, you know, sort of messing up your code. But I suppose you maybe could do that in the terminal, in the console anyway. But I'm sure it's got a bunch of other features. But for now, you can just sort of play around with it. But yeah, in a way, I do think R has the advantage of already populating the environment quite well. But I suppose if you've got a lot of variables on here, you might want to isolate a certain function and just play around with them. So it can be helpful in that sense.
Yeah. Or if you want to apply a function to a series or, an array or something like that.
That's true, yeah. Yeah, like if you've got, like Jules mentioned before, text mining, you're often applying functions to a massive column of data. So perhaps you want to apply that and then have a look at the first row. But you want to do it in a nice little safe environment, check everything works, and then you can stop and exit. So what do we have next? Okay, yeah, so for those that are still hanging on, we've got
13 people still.
Oh, okay.
13 people want to know about scope.
Not bad. Okay, so yeah, variable scope. So this determines where in your code a variable can be accessed. So you can think of it like rooms in a house. So some people like analogies, some people think, ugh, just doesn't work, but sometimes I think they don't really work. You know, when someone says something like, oh, that's like 20 football fields, I just think, I can't really picture that in my head. Yeah. So you can think of it like a house in a way. So global variables are like the living room, they're a communal area where everyone can access and hang out. Whereas function scope is like a bedroom in that it's private to that function. So those variables that are created in that function are private to it, okay? They can't be invoked. You can't go outside that function and then use a print statement that prints out that variable. It's local to that function, if that makes sense. So understanding scope helps you avoid confusing errors where variables seem to disappear. I mean, do you have anything to add on this, Jules?
Just that it can be really hard to remember where you've scoped things.
Yeah.
So you can even temporary scope within a function that like it's really hard to remember that temporary value won't exist outside of the function. But
yeah, definitely. And hopefully this little scope example will help. So yeah, it kind of looks nightmarish when you try and put code on a PowerPoint. It's just sort of oof. So here we have a Python example. So I'll just talk through it. You might be like, I don't really get it, and then we'll go through it in code. So the variable name here is global, okay? So remember how we talked about its scope, you know, think of it like a house, and global variables are in a living room, you can be accessed by anyone, okay? So this name here, this name variable, which has the value Alice, can be accessed by everyone, okay? Whereas we've got this message variable here, hello, and that's local to this function greet. So remember how we said think of local functions like in their own bedroom because they're confined to a function. So it's private to that. It can't be used outside it. So that's all going to execute fine, right? Because it's just using this local variable here, and then we're going to print basically the message hello, and it's local to that function, so we'll be able to do it. The name here, which is Alice, which is global, so we'll be able to do it, right? Because it can be accessed by anyone, so it can be accessed within this function. However, what we have here is another function called farewell, and basically this shouldn't be commented out. So I'm going to uncomment it when I show you the example, but we have goodbye followed by name, which is fine because name is a global variable, so we can use it even though it's within this private function. But then, sorry, it's not uncommented, but when it is uncommented, we're trying to use message. And what's going to happen here is that you're going to get an error. Why? Because message doesn't exist in this function. It's not a global function. We've not defined it within our function here. It's been defined in another function, so we're not going to be able to use it because it's private to that one. That makes sense. So we're going to do the same thing as well in R. So exactly the same function and exactly the same error message are what we're expecting. And that will hopefully illustrate scope. Okay, so let's move that away. Where am I looking? Scope. Okay, so let's clear this. We don't want to be in the debugger. I want to be in the terminal. Oh god. Okay. Right. So let's just things a little bit bigger. Can you see that all right?
yeah, that's fine.
Okay, so what we'll do here, we'll just basically create these. Oh, it's so annoying that I don't know the shortcuts that well. And the shortcuts don't seem to work for me. Okay, so you can see we've run up to here, right? So what I'm going to do first is I'll run greet, okay? And that's our function which uses the global variable, and it's also, we've got a local variable we've defined it called message. That should work perfectly. So let's go ahead and try that. So we should see the output, hello Alice. Yep, that's worked brilliant, okay? Whereas here, what we're trying to do is we're trying to use a variable that's been created in another function, okay? So functions like bedrooms, we're trying to take something out of someone's private bedroom, so no. So what we'll try and do now is run this farewell function. Yep, and what it's telling you here is, remember how we went through different errors at the start? It's saying you got a name error. Why? Because message hasn't been defined, and that's why scope is important. And also, what you could do is you can use your debugger on this, and that'll help you out with scope. So if we run the debugger here, can you just run it? Oh yeah, run debug. Yes, Python debugger. Uh-oh. Oh yeah, there you go. So it's telling you that that error has occurred, but has it created our variables for us? So yeah, you can see here that we've got a global variable named Alice, but our function variables, does it show us in there? You can fiddle around so that you can move watch down. I actually don't know how to do it at the minute. Function variables. Yeah, I'm not going to get too caught up on that because I know we are short on time. But basically, play around with the debugger and you will be able to find those local and those global variables.
Yeah.
And let's have a look at. So what we'll do here is we'll just clear that environment panel because we're on a new script here and we don't want it to be cluttered with all the old stuff. So what I'm going to do here is I'm just going to run these lines. And we should see this gets populated. Okay, so it shows you here that we've got our function farewell and our function greet, and we have some values here. And it's not actually telling us if they are, maybe it'll tell us when we run them if they're local or not. So we run greet, and you can see that works great. We've got the output hello Alice. But when we run farewell, we've got an error. And for some reason, message actually is already a variable in R that's related to something. So I had to rename it message underscore text. But yeah, you can see we've got that error message. It says rerun with debug, and what happens if you pick that?
Just wanted to point out when you ran hello or greet.
Oh,
yeah, when you ran greet, it didn't put a new value in the environment for message text.
Huh.
So that might be a way to think about the difference between local and global values, because it did put name equals Alice, but it didn't put message text equals hello.
Yeah, that's a very, very good point. So yeah, if if you're not seeing that come up as a local variable, then it's not going to be a global variable. So I know we hit a few roadblocks there. That's always common in these live demonstrations because no one's a perfect coder. Yeah, but just to wrap up, I don't know why I need to go play from current slide, don't I? There we go. So yeah, just to say thank you to those that have attended the YouTube live stream. If you are struggling with any of those concepts, or you just want to reach out with maybe a problem that you're having related to the content, you can email me. You can also find me on my work Twitter, which is listed there, and you can also find the UK Data Service on Twitter, where you can follow us for.
I think we might be off of Twitter.
Oh.
Yeah. Find us on LinkedIn.
Oh, we are. Oh, okay.
Yeah. I think we're officially dropping Twitter as a platform for I don't know, lots of reasons.
It's a bit of a dumpster fire at the minute, isn't
it? I would say we don't have any. Do we have more Code Anxiety Club scheduled?
Yeah, so the one I advertised at the start is on the 17th of February. So that's going to be an open Q&A, so you can just come along and ask any questions related to coding. Or any of the content that we've covered that you might still be stuck on.
Nice. All right, well, I think that'll do it for today. Thanks so much. Looks like we got quite a few people on the live stream. So that's also something to celebrate. And maybe people will come along in 2 weeks. 2 weeks? No, at the next session to ask questions. We'll see how that goes.
Pretty good.
All right. Thanks, everybody.
Thanks,
Okay.
everyone.
I'll let the live stream catch up, then I'll end the
Yeah.
stream. Okay.
All right. Thanks.
Bye.
Bye.
Bye.